Hello students. Today we're going to work through some word problems involving scale drawings. Let's go. Imagine you went for a walk and you recorded where you started and ended on a map. According to the map, you went about 3 centimeters. Is there a way to figure out how far you actually walked? Yes. Almost all maps have a scale to help you figure this out. But what does this mean? Scale is a ratio between the size of something in real life and its size on a map, model, or drawing. In this case, 1 centimeter equals 1 kilometer. We can also write it like this, or this. When working on scale problems, it's best practice to place the drawing or map distance over the actual distance, just so you can stay organized with your numbers. We can then use the scale to find missing values. In this case, the scale is simple to use since it's a 1-to-1 ratio. Meaning, if you went 3 centimeters in the map, you would have walked 3 kilometers in real life. Now that we have the basics down, I think we're ready to take on some other examples. Cora created a scale drawing of a cruise ship. The ship's main deck is 3 millimeters long in the drawing. The real main deck of the ship is 90 meters long. What scale did Cora use for the drawing? It looks like we have a blank to fill. We want to know how many meters 1 millimeter represents in our drawing. Let's find it. Remember, scale relates the measurement of our drawing to the actual measurement. So let's find those numbers from the problem. 3 millimeters is the drawing length. So let's write 3 millimeters as our drawing length in the ratio. And 90 meters is the actual length. So let's write 90 meters as the actual value in the ratio. 3 millimeters to 90 meters is the scale we put together. Now let's reduce. Both 3 and 90 are divisible by 3. This gives us 1 millimeter to 30 meters. We got it. The scale is 1 millimeter to 30 meters. Good start. Let's try another one. Wyatt created a scale drawing of a city park. The scale he used was 1 centimeter to 10 meters. In reality, a beautiful fountain in the park measures 50 meters in diameter. How wide is the fountain on Wyatt's scale drawing? Again, let's start with drawing to actual. In this case, the scale is given to us in the problem. The drawing length is 1 centimeter, and the actual length is 10 meters. Let's write 1 centimeter over 10 meters. What else do we have? We have the actual width of 50 meters. So let's set our scale equal to another ratio with 50 meters on the bottom. But how do we find the drawing width? Let's multiply. In order to go from 10 meters to 50 meters, we need to multiply by 5. And if we want to keep this scale in proportion, we also need to multiply the top. This gives us 5 centimeters over 50 meters. We found it. The width of the scale drawing is 5 centimeters. Nice job. Let's try another one like that. Brinley is designing a scale model of a soccer field. Her chosen scale is 1 millimeter to 5 meters. The soccer field is 18 millimeters long on the model. What is the actual length of the soccer field? Again, the scale is given to us in the problem. The drawing length is 1 millimeter, so let's put 1 millimeter on top of our scale. And 5 meters is the actual length, so let's put that on the bottom of our scale. We know the model length is 18 millimeters, so let's extend our scale to another ratio with 18 millimeters on top and the missing meter length below. In order to get from 1 millimeter to 18 millimeters, we simply multiply by 18. So we'll need to multiply 5 meters times 18 as well. This gives us 90 meters. The length of the soccer field is 90 meters. Nice work. Thank you for working through these scale problems with me. Always set your drawing lengths over your actual lengths, and you'll do great as you practice more on your own.